Okay, welcome to revision class. I think we check your materials. Make sure you have these materials. Number one, you should have. I mean, if you have your book with you, lah. If you have PDF, then if you're using PDF, then no problem. Just make sure you have this short notes with you, color notes. Okay. Then the second one will be exercise, the writing one, which looks like that. Okay, writing one, yeah. And then you have Form 4 model paper. Because we won't be doing Form 4 revision because there's so many chapters, right? I mean, it's very difficult to finish in a short time. So I prepared model paper for you. Model paper is fully Form 4. So what you can do is you try out yourself at home, right? So I have two sets of model paper, which only has Form 4 chapters. Okay. So you try out, the answers will be available in the QR code in the first page, or you can go to I think the QR code will be a lot easier for you, right? Or you can go to where you click the website where you click into the class, okay? But or else you just scan the QR code lah. So Form 4 model paper for you, yeah, on your own. Okay, so today's agenda, we want to focus on chapter 1 and chapter 2, Form 5 chapter 1 and chapter 2. So I'll be doing more on like exercise with you, like through exercise we try to recap like that. Like I won't be like going one by one and then read all of the details for you. Okay, so the short notes is to shorten your study time so you can spend more time on exercise. So don't try to sit down and memorize and read and spend a lot of time on just reading. Actually, the that should be the least amount of what you should do in your revision session. You should spend more time in doing exercise. So short notes very simple. It's just like 2 pages, like one piece of paper for one chapter. So it's meant for you to finish studying in maybe half an hour for one chapter. Then you spend maybe another hour just to do exercise. Okay. So that's the purpose of the short notes. So please have your short notes with you and your exercise side by side. This one, yeah, side by side. So we're going to chapter 1, and let me quickly brief you through the important things and we try out the questions. Okay. Yep, all good already. Okay, so chapter 1, right? The first part is about learning all the different types of microorganisms and then the characteristics. So I will brief you through important things, but I'm not going to read one by one. So the first thing you need to know is what is normal flora. Normal flora, it means good microorganisms that does not cause diseases, which are microorganisms that stays on our body. So like for example, your skin has a lot of microorganisms on the surface of your skin, your small intestines, your upper part of respiratory tract, your urethra. So these are areas where microorganism lives on you to help you out with different things. Okay, so maybe like to prevent other microorganisms to fight pathogens or to produce certain vitamins for you in your intestines and encourage growth of certain tissues. So they are good microorganisms. Okay. So normal flow. Of course, you need to read the details. Now my job today is to brush through important things. You absorb as much as you can, then the details you need to read through. Okay, so these are the 5 categories of microorganisms. You must know their special characteristics. So each of them have their own different special characteristics, but we separate them based on size, shape, nutrition, habitat, and reproduction. So long story short, let's just be quickly on this part. So fungi, right? There's only 2 types, yeast and mucor. Okay, the way they makan is saprophyte and parasite. So saprophytes are to digest dead things, right? To break down or to decay dead organisms. Okay. That's the way they makan. And the second one is called parasite. Parasite is where they make you sick. They live in a host, they get their nutrients, and then they make the host sick. Okay. So the method of reproduction, budding and spore formation. Okay. So algae are green microorganisms. They make their own food through photosynthesis. No saprophytes, no parasites. They live in water with sunlight, and reproduction is binary fission and conjugation. Binary fission, conjugation. Okay. And protozoa. Protozoa are microorganisms that live in water. They are like the fish of our world. Okay. We have only two types here to learn, which is paramecium and amoeba. Okay. The way they makan is photosynthesis, parasites, and phagocytosis. So phagocytosis is only for amoeba, where they swallow food like you and me. They engulf the food. Like they have the hands called pseudopodia to grab the food and they swallow. Okay. So that's special for amoeba. Okay. Reproduction, binary fission and conjugation also. Okay. Okay, bacteria. Bacteria classify based on shape. Streptococcus, or we say coccus, spirillum, bacillus, and vibrio. Four shapes. So coccus are round shapes. Spirillum are spring shapes. Bacillus are like long rod shapes. And then vibrio, like a sperm shape. Okay, four shapes. That's how we classify them lah. How they makan? Photosynthesis, parasites, saprophytes, all three. Okay, where do they live? They basically live everywhere. Everywhere. Anything on this earth may have bacteria on the surface. Okay, so they are basically everywhere. Okay, so binary fission and conjugation. Okay, good. Okay, virus. Virus is the smallest microorganisms. They also classify based on shapes. These are the shapes. Influenza, round shape. Mosaic is like coil shape. Adenovirus, okay, and bacteriophage. These are the shapes. So they don't makan, they don't need water, they don't need to sleep, they don't need to rest, they don't need to excrete. They basically don't need to carry out life processes. The only thing they need to do is to live in a host and make more viruses, produce more viruses, and spread the viruses away. Okay, so that's the only motive. The only motive on this world is to have more viruses and spread diseases. Okay, sounds evil, right? Yeah. So that's basically the summary lah. But I really compressed everything into this box lah. So not as crazy as like you read your textbook or reference book. There will be a lot of pages, a lot of unnecessary stuff. Okay, you good? Okay. Macam tu. So then I don't want to do this question because these are very simple questions. So like number one, yeah, you want to try out number one, number two, like that. Those are simple questions. Okay. So then after this, we get into I would say the first important part, which is the factor that affects the growth of microorganisms. So just like you and me, every living thing on earth require a certain factor to survive, right? You need water lah, you need makan lah, you need to have a shelter lah, you need protection lah, blah, blah. So same goes to microorganisms. They need 1, 2, 3, 4, 5 factors. Okay, so humidity means water lah, water lah. Everyone needs water, right? No one can live without water. So if it's in a damp condition, they like it. If it's in dry condition, they will less active or they will die. Okay, light. Only microorganisms with chlorophyll requires light. Everyone else doesn't. So fungi, bacteria, they all don't live under the sunlight because they hate sunlight, because sunlight has UV. Ultraviolet rays can kill microorganisms. Okay, nutrient, everyone need to makan, of course. Temperature 35 to 40 is the best. Like you and me, our body temperature, that's the best place for microorganisms to grow. Too cold cannot, too hot will die. pH value 7. 7 is the optimum pH value. Too sour, too acid, or too alkaline, they won't like it. Okay. So there you go. These are the 5 factors. But this particular subtopic, right, is going to be in experiment form, which means like section A or section C. Yeah, so it will be in experiment with 5 different factors, which I would want to do one with you now. We try out some questions so you can get a get a an idea of it. So maybe you go to number this one is this one, is it? Okay, where did you go? Okay, can you go to number 5? Page 5, question number 4. So let's just do a pH value question. All good? Question 4, page 5. Okay, so like I said, it will be in experiment form. So experiment form is like that. Yeah, your hypotheses manipulated, the constant variable, inference, operation definition. Okay, so always when you come to section A question or experiment question, the first thing you need to find out is your manipulated variable and your responding variable. So usually it will be in your question or on the table. Okay, so right, already got it here. pH on the growth. Okay, so pH is my manipulated variable. Growth will be responding. So pH is my factor. Okay, so all these 3 test tubes are with nutrient broth. Nutrient broth means like soup. Okay, soup with nutrients, nutrient broth. Okay, then we add bacterial culture. Bacterial culture means good bacteria. Then we let them party inside. When they have food, they have suitable condition, then they so they party. But which one party the most depends on pH value. Okay, so we have acid, alkaline, distilled water. So from the result here, right, we can tell that when it's neutral, the nutrient broth becomes cloudy. Become cloudy means there is a lot of microorganisms, means they like it a lot, so they party in neutral. Then the rest is like not really lah, slightly party. Okay, so from here we can tell that microorganisms likes to grow in pH 7, or we say neutral lah. Okay, right? You need to analyze what is happening here. Okay, good. So then we have to fill up the answer. So manipulated and responding, copy answer. So it's always from the table. So you copy your pH value. Oh, this is not responding. I was thinking about responding. So no, this is responding, but this is constant. Okay, then we cannot write. But at least you can write this down, pH value. Okay, constant variable means things that must be fixed, things that must be fair. So no matter you acid, alkaline, distilled water, something that must be fair here will be, remember, never write apparatus like, the size of the test tube, the brand of the test tube, right? No, it's not going to be things like that. It has to be things that is measurable. It has to be things that is material you add into it, not the apparatus. Okay, so to be fair, no matter acid, alkaline, or distilled water, all 3 must have the same volume of all this. Okay, must be the same volume of nutrient broth, same volume of bacterial culture. Then that is fair. Okay, so manipulated done pH value okay, like then constant variable will be the quantity or the volume of nutrient broth. How many cm cube we all fixed all together. Okay, so there you go. Okay, you good? Right, next one, optimum temperature, no, optimum pH value, which is the best pH value is obviously pH 7, no? Like you're right, pH 7. And inference, basically what you just answer in B1, right, is your observation. right? Your observation is period 7 is the best, right? Okay, then now it's your inference. You remember your formatting. You need to remember formatting for section A, like observation plus reason. So reason usually will be your manipulated variable. Okay, so your observation is what? Your observation is, oh, period 7, best. Why? Why? So now you need to answer the why part. Okay, so how? Okay, you bring this down. Uh, neutron broth in pH value 7 is very cloudy. That's your observation, right? Something like that. That's the first part you want to say. Neutron broth is very cloudy at pH 7. That's your observation. Can you all start that first? Yeah, neutron broth is very cloudy at pH 7 because then you want to continue the because part, right? So you all start with the first part, first half observation. Right? You write first without me. You good? Because what? Because why cloudy? Cloudy means a lot of bacteria is partying. Because bacteria grows rapidly in neutral condition, or you should say pH 7. That's the place that they like. Or because bacteria reproduce or grows rapidly in pH 7. So that's the reason why there is a very cloudy solution. You understand? Yeah. Okay. Then you won't be saying because pH 7 no, because pH 7 that's not explaining at all. That's not the reason at all. You must say, yeah, I know 7 and then why? And then 7 is the best place for them. Okay? So because bacteria grow and reproduce rapidly. That's the correct word to say lah. Grow and reproduce. Okay? Grow and reproduce. So all these answering technique must follow lah. That's where you lose your mark sometimes if you just randomly answer. You follow the answering technique, then you're within the frame, then you will be safe. Okay. So the next one will be the annoying one, operational definition. We've done this enough in class, right? You all should know what am I saying, but I think we need to repeat the format again, right? So it's subject plus responding variable plus procedure. Okay. Okay, so subject is what the question is asking. What is growth of bacteria? Huh? Growth of bacteria grow lor, right? Hard to explain, right? So the easiest or the best way is to write something that people can see. What is growth of bacteria? Responding variable. Growth of bacteria. Oh, grow bacteria grow is the like the neutron broth cloudy the neutron broth cloudy when the neutron broth go, you see like cloudy, then got bacteria. So the growth of bacteria is the cloudy. You get it, right? It's what you see. It's way better in explaining. So we have to incorporate this. It's about the cloudiness of the neutron broth. Okay. Then procedure is what? Procedure is, I think when it's very cloudy, it's at pH 7, right? So we will be saying like, oh, it's very cloudy when, it's in distilled water for, the question says how many days? For 2 days. Like that, that's your procedure. Okay. For 2 days. So three part. Growth of bacteria is your subject, and then responding variable is this one, and then you add on the factor with the duration of the experiment. Okay. Okay. So honestly speaking, this is just 1 mark, and usually in exam like one question only, or maybe maximum two. So if really you struggle and you feel like you want to just skip this, I think that's okay. because this is not easy and a lot of people struggle and a lot of people hate this part. But anyway, it's just for 1 mark. If you can get over it, it's just 1 mark, right? But we're talking about, 1 mark could be A, 1 mark could be B, 1 mark could bring you to up next grading already. But you try your best. So growth of bacteria is a process. It's a process. It's not a substance. It's not a solution. It's an ongoing process that causes nutrient broth to become very cloudy in neutral condition after 2 days. So this is my responding. Very cloudy. Where? In which one? In the neutral one for 2 days. After 2 days. Okay, you good? All right, that's a factor question, factor that requires by microorganism. It's a very standard mm, more like a must ask question in exam. Very high chance you need to know how to answer this, right? So there's other factors for you to try. Of course, I can't do every single factor with you. So my point is just to brush through, you get the idea, you try the rest at home, okay? So done this one. Let's move on, okay? Like moving in 10 seconds. Okay, all good. Let's go. So um, after factors, the next one will be useful microorganisms. Um, hmm, I mean, you just have to roughly memorize a little bit, like what are they for and uh, what are they there to produce. So there is mainly three categories like industry, agriculture, and medicine. Okay, so industry usually means like mostly food, lor. Bread, what else? Beverage like yogurt, okay? Leather goods, not for food, but yeah, leather goods is in industry. Agriculture, you have animal digestion and nitrogen fixing bacteria, nitrifying bacteria in Form 5 Chapter 2. Okay. Then medicines, you have insulin, penicillin, which is the antibiotic, and vaccines. Okay. Um, then we have one part here says lactobacillus sp bacterial serum. So there's this thing now. You just have to be aware of this word serum and be aware of this eco enzyme cleaning solution. Well, basically, it is to clean up our daily life stuff, like for example, sewage, poop and pee. How would the indoor water do all the cleaning? They have to use all these bacteria to help to digest, to make fertilizer, to remove smell. So these are all good microorganisms that helps us every day. Just make sure you know the words. If you see this word ecoenzyme, you know it's in chapter 1. If you see this word serum, bacterial serum, it's in chapter 1 under the good microorganisms category. Okay. Okay. So then I think we have one to try. We shall put microorganism this one. Okay, why not line number page 8? Okay, so Diagram 2.1 shows an application of useful microorganism. Okay, so very simple. Can you write down A, what microorganisms involved in making bread? How can we not know, right? Can you do A dot dot? Okay, and then B. So what's B? Here says root nodule. By the way, this is your Form 5, Chapter 2, nitrogen cycle, but it's also from here. Agriculture, root nodule, the bacteria that lives in this kind of plant, or we say root nodule, is called the nitrogen fixing bacteria, or you can actually write the fancy name if you want to, but I don't think we can remember in exam, right? So just write nitrogen fixing bacteria. So for A will be your yeast, and then for B will be nitrogen fixing bacteria. Okay, you good? Okay, next, the importance of B. Let's copy answer. Why nitrogen fixing bacteria so important? For what? Here, remember that is to this is the only plant type of plants that has this bacteria that helps to absorb nitrogen in the air and convert into nitrate compound, which is like fertilizer like that, for the soil, for actually for other plants also. Okay, not only for themselves, but this is to supply for everyone else. So before the era of fertilizer, right, we have to wait for the plants to do it lah, like by the nature. But after the invention of fertilizer, right, then we don't really care anymore lah. We just use fertilizer lah. That's way more faster. But this was the natural way of producing fertilizer. Okay, so your answer is this one. Okay, like, can we just write food and nitrifying bacteria? You mean for A, is it? What are the microorganisms used for? Let me think of the question. Why does it sound like what are the microorganisms used? So no, I think the question is what are the microorganisms? That's the question. What are the microorganisms used or exist? So we must name the uh we must name the bacteria. Or you actually mean B? No, I don't think you mean B, right? The importance of microorganism in situation B. Wait, which one do you refer to actually? Do you refer to A? Oh, so cannot. So question must ask for what are the name of the microorganism. Like that. Okay. Hmm. Okay, so you're done with this one? This is the answer. Okay, all good. Okay, so next one. What bacteria can be used to make serum to treat the sewage? Oh, this is really asking for the name. What bacteria can be used to make serum? Serum, guys. Serum. What bacteria? Like the name is Lactobacillus sp bacteria. I don't have to write the word serum, just bacteria. Then can bacterial serum means the solution, the liquid. But the question is asking what bacteria, right? Let me read one more time. What bacteria can be used to make serum? Okay, correct. So it's called Lactobacillus sp bacteria. Sp means species, short form sp dot, to make treat sewage, right? Yeah, currently it's sewage. So there you go, just like that. Names, just memorize them. Okay, you good? All right, next one. A student is infected with bacteria, and then the symptoms is inflammation in airways. Means when in your trachea, when you breathe, inflammation happens inside. And then cough, fever, and difficult breathing. What is the possible disease suffer and one way to treat? Okay, honestly, this part is very straightforward. Your follow up. Okay, there's one last part in your chapter one that especially give you these three diseases. Pneumonia is lung infection, which is the one that we just had just now, saying what inflammation lah, and then cough cough lah. Yeah, it's caused by bacteria. How to treat? We have to take penicillin or we have to take antibiotic. So antibiotic can only kill bacteria diseases. Okay, so since we're here, let's continue a little bit. Athlete's foot. Athlete's foot, right? It's also called the tinea, which there's skin infection by fungus. So you have to apply cream. It's called antifungal. If those who have your skin issue, you've been applying some creams, right? I'm pretty sure you know this name here, lah. Clotrimazole. It's a very common antifungal cream. Shingles is virus infection. You have to take antiviral, acyclovir, okay, antiviral. So bacteria, antibiotic, fungus, antifungal, virus, antivirus. So currently the question says bacteria, so obvious, okay? The thing that you should take is antibiotic. But what is the possible disease? Then in your textbook, we only learn one. Yeah, this is cough, cough, and lung infection. So the answer is pneumonia, everybody. Okay? Pneumonia. And then what should you do? The next question, right? Asking for what should we take? So you can say take antibiotic. So just one way to treat. Yeah. Take antibiotic. That's it. Don't have to write the word penicillin if you don't remember. Just write antibiotic. Okay, good. Yeah, so small parts, ding ding dong dong like that. And then this one will be the aseptic techniques or the sterilization. And let's maybe just brief you through the important things. Okay. So aseptic technique is a healthcare procedure to prevent infectious disease and also to remove existing pathogen. That means to prevent and to cure. Like if you haven't got anything yet, that's to prevent. If now you have it, you want to remove the pathogen. So we have sterilization, a very common method to kill microorganisms. Okay, boiling 100 Celsius with hot water. Antiseptic for body, for skin, all right, for wound. Yeah, so these are some of the very famous or very common antiseptic that you might have used. Disinfectant is not for body, not for living things. These are for objects, the bed sheet, the toilet, the swimming pool, the floor that you mop, whatever that is non-living thing, then we use disinfectant. So this is the difference. One is for body or for wound, one is not for wound because it can destroy the cells. And lastly, ionizing radiation, which means like X-ray, gamma, UV. We all use this in hospitals, not in our common day. Okay. So I think this part quite straightforward also. You can try out the work, which is this one, this question on your own, which I'll skip. And so number 9 on your own. Yeah. And then we shall go to page 11, actually 10 and 11. And one last thing about this part, okay, will be the antibiotic experiment. Okay, you good? Page 10 and 11. So after this, you have this part here, this one. And because this is short notes, right, I do not have space to put in the whole experiment, but I'll do the exercise with you. So antibiotic is only to kill bacteria, yeah, everybody. If you have something that is caused by a virus, doctor will not give you antibiotic. Okay, so it sounds like that. So this is the question. Okay, in section A, or I should say experiment, the antibiotic question will have one factor here, which is difference in concentration, right? Concentration of antibiotic. Okay, this could be one. The other type of question will be giving you types of antibiotic. They may give you type A, type B, C, which brand is better like that. But or else most of the time will be concentration. So this is my manipulated variable. And then growth of bacteria will be my responding variable. Remember, you must always find out your manipulated and responding first in section A. Okay, so let's observe a little bit. This is high concentration antibiotic. This is low concentration antibiotic. So what we do is a petri dish with nutrient agar, nutritious jelly, we spread on the surface. Then we will place bacteria into it, we'll inject bacteria to the surface. So the bacteria will like it because there's a lot of food, right? There's a lot of nutrients, so the bacteria will party, right? So then the next thing is we will place antibiotic disc. It's like a filter paper, but we soak in antibiotic and then we dip it in. We put it on the surface. So suddenly you put it on the surface, it's like it's like police going to a clubhouse and do a spot check like that. Okay, suddenly doom, off the music, turn on the light. All right, everybody, attention please. Girls on the left, boys on the right. Okay, please have your IC out. We need to do a spot check and see if any illegal things are going on. So when the antibiotic is there, right, the antibiotic will start to kill the bacteria around them. So you can see this clear area is bigger and this is smaller. So the clear area represents how good the antibiotic is. So obviously, the higher the concentration, bigger the clear area, right? Because higher concentration of medicine can destroy more bacteria. Then this one is smaller. Okay, this is how the experiment look like. Okay, like question, observation. So you need to write down what you see. This is what you see. Oh, I see the high concentration antibiotic one, the clear area bigger bigger than the low concentration that's what you see. Can you all try? I want you to try this question on your own, especially to familiarize with the formatting. So you can do a comparison sentence saying that this one is bigger or larger than low concentration. Like Joe, everybody on your own. You try on your own way first. Don't worry. Just try. We will correct it later, but you need to put it in a comparison sentence. Okay? So you good? Okay. Like no matter what your answer is, just do some minor correction or you've been waiting for my answer. No lah, you all try lah, you all got to try. Okay, so quickly you do some correction. We move on to question B. Okay, so I'm saying the clear area is bigger for the higher concentration compared to the one that is lower. So comparison. Okay, so inference, everybody, formatting again. Can you have your observation and your reason? Okay, so I know it's going to be very long. So if you want to be lazy a bit, you can do this. Clear area around the antibody is larger because, so you can bracket like that. For now, if you're feeling lazy. Or else you can write the whole thing. So clear area around the antibody is larger because okay, why the concentration higher than bigger? Concentration higher bigger means what? Means you manage to kill more people around.
you get to kill more bacteria around. You are the soldier with more ranking. You have like 3 stars one. You've been experienced, so you can you can kill quite a lot of enemy around you. With this newbie here, not very experienced, you maybe can kill someone on your left, then someone on your right with the sword coming towards you, then gone. Yeah. So it's about whether you have the ability to kill more or not. So the clear area around the high concentration is larger because it is able to kill more or destroy more bacteria. So the main point here is more. Both also can destroy, but it's just that this is higher concentration, so destroy more. All right. So assuming you bracket this down like that, which I have it lah, here. Because why? Because higher concentration is able to destroy more. I think missing word here. Destroy more bacteria. Destroy more. Okay, good. Get used to all the formatting. Okay, responding variable, we already got the answer. You can bring it down. So basically this one, right? But because at this current experiment, it's about the clear area though. If the clear area big means lesser growth. If the clear area small means you don't manage to kill as much, right? So usually in experiment, the responding, we will write what you see one rather than the real thing. The real thing is the growth, but what your eyes can see is the clear area. So let's give it a measuring or like an adjective to it. So it's about how big, right? So we say size. Or another word you can use is called diameter. Okay, size of clear area or diameter of clear area. There you go. Measurement important, huh? Okay, I think it's time for you to shine again. You try one more time, Lisa. Subject. Okay. Subject plus responding variable plus procedure. Jom. So your subject is antibiotic. What is antibiotic? Antibiotic is then you try to relate to your responding. Your responding is different. The big area or the small area one. When you use what type of antibiotic? So obviously you want to choose one side. Either you want to write the big size of clear area or the small one to talk about. When you place on high concentration or the low concentration one. You try on your own first. Okay, I'll show you in a while. Okay, you good? Try first, never mind. At least you get to do the first two, subject plus responding variable. So you have to think of what word to use for antibiotic. Is antibiotic something? Antibiotic is a principle. Antibiotic is a
it's a process. Antibiotic is a, that's the word you have to think of lah to start your sentence. So obviously antibiotic is not it's not a process, right? It's not a principle, right? It's a something, right? So it's a solution, or you can write it's a substance, or it's a medicine also can actually, right? Indeed, it's a medicine. Okay, like Joma. Why got two answer one? Sorry, sorry. This one don't one. This one. Okay. So antibiotic is a substance that can produce larger clear area around the antibiotic disc when higher concentration antibiotic is used. So I'm choosing one side. I'm choosing the higher concentration one. Instead of being general, I want to be specific on either one. So what is antibiotic? Antibiotic is you see lah, the clear area big means wow good means high concentration antibiotic. Uh, okay, so these are the three components. Okay, good. Maybe some correction, then you get to know what's the difference between yours and my one. And then question E, shall we? You need to take on the microorganisms that can be destroyed by antibiotics. So, like I said, antibiotic can only kill bacteria, right? So between these three pictures, do you know who is bacteria? Sometimes easy questions like that, right, could be challenging because you don't know the shapes, you don't know the picture, you don't know who are they. It could be challenging. So the first picture is called Chlamydomonas. Chlamydomonas, which is an algae category. So it's not bacteria, it's algae. So the second one is called Bacillus, which is which is bacteria category, correct. And then this is influenza. Okay, influenza virus. So of course, Bacillus is under bacteria lah. Influenza is virus. Okay, you're good. Mm-hmm. So that's the second experiment for the chapter number one. Okay. Then this one you can try lah. This is a shingles, I think. And then we have okay. So then I think I'm gonna do one question with you with section C question, which is the experiment question. Okay. So you're good with what we have just did. Can you get yourself like a line paper? Do you have line paper? Or can you maybe find some space, uh, any empty space on the book you can write, or else I would suggest you get a line paper lah. So can you also turn to 12? Okay, 12. Then I'll do one of this question with you. I'll show you the steps again. It's not new. You've been doing this for the past year. You should know how, but of course, if you don't remember, I'm here to repeat the whole sequence for you again. So everybody, page 12, question 12 also. Get a line paper, yeah? Then where should I write actually? I'm just gonna add a new page. Okay, so ready? Let's go. Okay. The growth of microorganisms is influenced by several factors, such as temperature, pH value, humidity, light, nutrients. So different pH value will affect the growth of bacteria. Okay, so I think we land on one last factor here, which is pH value lah. That's what the question is asking. So carry out and investigate to study how pH value affect growth. Okay, nice. Like pH value, growth. That's your manipulated and responding. Remember, experiment is always about these two, so we need to find out the variables first. Okay, right. So your report should contain the below. Okay, so these are the items that you want to answer. But regardless, this is a pH value question.
we must go back to our original experiment. So sometimes question might give you story. I show you maybe like this one. See, they chit chat, they talk about something, but whatever it is, we still go back to our original experiment, which is the antibiotic concentration, high concentration, low concentration. So don't bother about the story. Um, I don't know why, but it's just so often that students got carried away. Whatever story is above, sometimes they make story, right? Then in this part, right, they literally write down the story, like continue the things in the story. Then gone, 10 marks. Bye bye. So no matter what story above, please close your eyes, take a deep breath. Think of the original experiment. Okay, so this is pH value, which is something we did lah, like just now. Something like that lah. This one lah, something like that lah. It's about this lah. Okay, it's for different pH value lah. Okay, okay. So, continue here. The first question, okay, it's asking for problem statement, right? Okay, you'll go on to your paper. 9A. Problem statement. Okay, you good? So this one has to be a question. At the end of your answer, you have to be a question mark because you're asking a question. Asking a question of what? Of manipulated and responding. Manipulated and responding. So you want to relate these two. So what question should we ask? Like, really meh? pH value can affect the growth meh? Really? Like when I go different pH, they change meh? Really meh? Like we want to ask the question. That's when you hesitate. Then that's why we test. You don't believe me? I test. I'll show you. But so first you have to ask a question. Really meh? pH value will affect the growth of bacteria meh? You get it? So usually we can start a sentence with words like, does the blah 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 on blah blah blah, will the blah 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 on blah blah blah, is the blah blah blah, that's usually how we ask a question. Okay, so let's say I'm going to start with does. Okay, does different pH value affect the growth of bacteria? See, does different pH value affects the growth? Like I'm asking, really, really, but I forgot to put a question mark. Okay, so really different pH value affects growth of bacteria. So I'm still in my frame. I'm still talking about my manipulated and responding. Okay, you good? Okay, there you go. Done. That's your um, problem statement. So the next one will be hypothesis. Okay, like continue. Hypothesis. Okay, good. Okay, hypothesis will be like usually we will do a the and the higher the, right? But that is when both of your manipulated and responding are numbers and they can fit the criteria. So for example, pH value, yes, it's number. Growth of bacteria in this case will be how cloudy the nutrient broth will be. Right, down with it, cloudy. So one of them is not number, the cloudiness of the nutrient broth is not. So you can't really do the. Anyways, pH value is not like you go higher than the better growth or the worse. The higher the no, higher also no good, lower also no good. pH 7 only good. So this is obviously not suitable for the. Okay. Since it's not suitable for the, then we go for the second type, which is we go straight to the point. I tell you, 7 is the best. You all get it? It's not higher, lower is better. It's 7 is the best. Okay? So that will be our hypothesis. Okay, but of course we want to put into a proper sentence, right? How bacteria grow. Bacteria grow and reproduce rapidly in pH value 7. There you go. I'm just gonna say like they like it. Bacteria grow and reproduce rapidly in pH value 7. Okay, so I'm still having my manipulated, I'm having my responding. Okay, I'm still in my frame. That's right. Okay, good. Can exam come up with form for experiment? I would say for your this term exam, very less likely because it's form 5, right? So teacher will want to give you new experiment. So very, very less likely to come up with form 4 experiment. But I cannot tell for sure, right? Because your teacher, I won't know what your teacher is thinking, right? So I would say not possible, but very low chance because usually they want to ask you new experiment. Um, so at least you know the formatting. At least you know the formatting because this formatting can apply in any question. So no point we memorize experiment, right? Honestly, just pray hard and leave the rest to the luck, to your luck. But you all must know the answering technique. Number one, problem statement must be a question. You must include your manipulator and responding. Number two, your hypothesis. Yeah, follow that one. Okay. So after hypothesis, factor that is changing and how to control it, and fixed variable. Okay, so factor that is changing and how to control it. The factor that is changing basically means manipulated variable, everybody. Okay, manipulated variable. This is a different way of asking. Okay, manipulated is what I just now. pH value. Okay, pH value. How to control it? Meaning, how can I make sure that you're doing the correct factor here? So since we're doing with three different factor, right? So we actually will say it out. We will say like, okay, we'll use three different solution of pH values, such as, then we need to list out distilled water, hydrochloric acid, what else? Uh, Alkaline will be sodium hydroxide solution, right? So you need to name what you are using. Okay. Yep. So let me just double check with the question. Did they do any restriction? pH value. Okay, so since nothing is restricted, let's just do all three lah. Okay. So use, how am I going to do it? I'm going to use three different pH value solution, or three solution with different pH value. Okay, such as number one, distilled water. Number two, hydrochloric acid and sodium hydroxide solution. These are the three things. Obviously, hydrochloric acid is acidic. Obviously, the last one, sodium hydroxide solution, is alkaline. Okay, this is factor changing and how to control it.
Okay, you good? Okay, like next. Or C2, it's not there. Fixed factor. Fixed factor means constant variable. Yeah, later I name them. I should do the fixed factor, constant variable. Okay, no matter what pH you use, remember there's three test tubes, right? Distilled water, acid alkaline. The inside, the materials inside that you use must be fixed, which is the volume or the amount of nutrient broth and bacterial bacillus, right? Or the solution. Okay. So then that will be a factor that is fixed. Volume of nutrient broth and bacillus sp. Okay. There's no the another one how to control it on it. Okay. All right. Then we go to D. D is oh my god. I hate this materials and apparatus. You need to list all the ingredients. This one I don't put high hope one usually. If cannot. It's really like if you get I think if you get less than I forgot less than 4 or 5 correct apparatus and material, then you get only 1 mark. And if you get lesser than maybe 2 or 3, then you don't get marks at all already. So anyway, I don't put high hopes on this one. We just try our best. So remember, there's 3 test tubes, and when there's 3 test tubes, there will be 3 solutions: the acid alkaline, and then we will have bacteria inside, and then we'll put a cotton wool to cover. Yeah, nothing much, not too fancy. Okay, so like uh, uh apparatus and material. Okay, so we have three sterile test tubes. Okay, means clean test tubes. 3 sterile test tubes. We have what is inside. We have now let's write all the apparatus first. 3 sterile. Okay, then we have cotton wool. Nothing really. The apparatus is just like then we say material that we put inside. Okay, so we have nutrient broth, bacillus sp culture. Okay, and we have 3 different types of solution, right? So we have distilled water. Acid will be hydrochloric acid and sodium hydroxide solution. Yep, that's all we need. So nice. Okay, you good? C, D, E. Come on. Yeah. Okay. Okay, you good? So what's E? Drawing of apparatus label. Okay, so drawing will be label diagram. So I name this as label diagram. Okay. So don't worry about the drawing it now because let's not waste time and wait for everybody to draw. So it looks like this exactly picture I show you again. Yeah, jap. Sekejap. This one. Okay, as for me, I'll just copy paste. Then you can leave like maybe I don't know 7 to 10 lines empty for the drawing. So imagine this will be your drawing and label them. Okay, it's okay. You leave it empty. You can draw later if you have time or you remember to draw. C D E. Okay. Yeah. Looks like that. I just copy paste the question that we did just now. So that's all right. You can leave it blank. Okay. So next and the last question, F will be safety precaution so that the investigation is fair. So usually safety precautions are things that you have to be careful of lah. Like literally the question says safety. Okay, because in this experiment there's nothing much too dangerous like burning chemical or fire lah then reactive metal lah. So in this case we would just write things that should be fair, things that should be fixed. So in this case no matter what solution that we use we have to make sure we use the same type of bacteria. To be fair takkan certain the first one you use this bacteria species and another one you another species, different species will affect the result also. You understand? So things that must be fair rather than safety because there's nothing much too dangerous here. And whatever we are using good bacteria, so they will not transmit diseases. Okay, so this will be safety precaution. Safety precaution. Okay. Okay, so for I think 1 mark only, right? Safety precaution to ensure that okay 1 mark only lah. We can choose. We can just write one or a few for you. Okay. So make sure I use the same bacterial culture. I give you a few more lor. What else? Make sure I use the same volume of the solution, or I should say the culture or the broth. Okay. So use the same volume of. So broth usually we use 5. So we write 5 cm cube. Okay, I can't do the uppercase lah. You'll do the uppercase 5 cm cube of nutrient broth. There you go. A full experiment. 10 marks. Nothing new. You've been doing this for the past year just to refresh your memory how you should follow your steps. Okay? Like wrap up. Then we move on. So conclusion, you need to get your manipulated variable and responding variable ready. Then you will go within the frame lah, as long as you're within your pH value and your growth of bacteria. So in this case will be the cloudiness if there is responding, but you see here don't have, right? If question asks for responding or factor that can be observed, then that will be your responding. So this is manipulated. Changing is manipulated. Observe is responding. So responding will be the cloudiness of the nutrient broth. Okay, the cloudiness of the nutrient broth. Okay, you good? Hmm. Um, okay lah. Jom, we go chapter 2 already. Chapter 1 搞掂咯 Settle. Settle. Kasih settle. Semua settle. Okay. Jom. 来 10 more seconds we move, yeah. Of course, I have the antibiotic one you can try also. If you don't know how, never mind, download my answer, just copy my answer one time. While you copy, you must brain lah. Don't just copy blindly lah. You must like like that. You must try to memorize a bit also. Okay, let's go. Joke. Um, chapter two. Oh, chapter two very big also. So yeah, and again, I can't go every detail lah. I'll pick a certain parts to talk about it. So the first part of chapter two is about balanced diet, it's about nutrition, it's about health, it's about calorie calculation, health issue, and then you have one experiment here, the calorie experiment. Okay. Um, yeah, I think the first part is very short. Let's try some work instead. So, Joom, let's go to page 15, question number one. Like page 15, question number one. Okay, Jom. Table below shows calorific value of three types of food. Okay, so we have roti, orange juice, eggs. So these are all per gram, kilojoule per gram, kj per gram. Okay, so this is how much Sarah took. So you just times together as a simple maths. Also, she took 300 grams, 250 grams, and then 100 grams, and calculate total calorific value. Okay, very simple maths. Kindergarten, right? Total calorific value equals to, so for bread she took 300, right? But for every gram is 10.2, so 10.2 times 300 oh. Simple maths oh. Then eggs 250, right? But every 2.5 per gram so 2.5 times 250 gram plus 9.5. Wait. Oh, see, I just showcase a very bad mistake. 2.5 is orange juice. Orange juice is 100. Orange juice times 100. There you go. 9.5 eggs times 250. Okay, there you go. Calculator. Calculator. Anyone got your answers? Please type to me. So I don't have. I, I'll wait for yours. Anybody? So everyone is waiting for each other, right? Nope, no one's gonna count unless you need to count. Maybe we have answers from from Amy. Hi Amy, can you give me your answer? Okay, before Amy. Is that correct? Kindly, thank you. But can we have more confirmation? 5, 6, 8, 5 kilojoule. KJ, because the question here is KJ. So we follow KJ. Okay, there you go. Simple maths. Okay, Joe. What's the full class for? How can you not know egg belongs to what, right? How long have you been living? Okay, please take your answer. Next one. What is meant by calorific value? Oh, copy answer. Calorific value is every 1 gram of food that is fully burned, how much energy is produced. So 1 gram of food fully burned is equals to 1 calorie. That's the amount of energy from 1 gram of food that is being burned. Anyway, you all copy the whole thing. Definition. Okay. Definition. Okay, you good? Yeah. Okay. Explain how total calorie intake of individuals is influenced by fast food and food operating restaurants that operate 24 hours a day. Sounds weird to you, right? But it's actually from your textbook. We actually learn about this. Eh? So fast food problem, right, gives you a lot of calories, a lot of sugar, a lot of artificial this, artificial that, and gives you a lot of bad calories. Number two, 24-hour restaurant encourage late night eating, meaning inappropriate meal times. Meaning you can eat very late night, you can eat whenever you want. It's actually part of your syllabus. It's not something extra one. Your syllabus actually talks about it. So we combine that together. But by the way, let's just talk about the next one together since it's the same page. Sarah suffered from diabetes. What is the cause and effect of diabetes? Is actually here, so I show you. Diabetes. What is the cause? Too much sugar over a long time. You like to drink sweet things, you like to eat sweet things over a long time. Effect, okay, affect vision, affect kidney, slow recovery. I will copy these two together to form the answer. And the 24-hour one is this one. Okay, Scully Goose, everybody. So it's actually part of that. That's a very small part. I think ding dong dong part. You just read through the rest, okay? Which I will not go through the details. Okay. Okay, good. Let's move in 5 more seconds. Okay, good. Let's go. So after this, which is a small part, the next will be the nutrients in plant. Okay, this one quite important also lah, huh? But I think the most important three nutrients for plants you must remember is NPK, nitrogen, phosphorus, and potassium. Because in chemistry it's K, right? So N, P, and K. Okay, that's for macronutrients. Micro, you agak-agak lah, one or two example, I just memorize. Okay, the function, I think not necessary lah, but I just have it on this page for you because your textbook actually give you all the details, but it's okay. You just look through, right? If you no time, don't want to look through, then never mind. We will see how we'll work around it, okay? Because that's not 100% coming out also, right? Okay, so nitrogen, phosphorus, and potassium most important because these three, right, will further bring you to the experiment now, which is the experiment of chapter 2, the second experiment. The first one was the calorie one, and the second one is this one, plants. Okay, okay. So what you need to remember of observation, this part will be the color of the leaf. This one. Okay, because so many things, right? Need to memorize the roots, need to memorize the fruits, the flower. Really, may. But from so many types of question I've seen, usually they will just ask for the leaves. So the rest you read through, not super important, but at least you remember the color of the leaf. So remember lack of nitrogen, yellow. Memorize only. Oh, yeah. Lack of nitrogen becomes yellowish. Lack of phosphorus becomes bluish green or like purplish. Okay. Lack of potassium, brown spot, and the edge of the leaves will die. So it's like the side is curling in and dying, and this is also like curling in and dying. So color, guys, yellow, bluish green, and brown spot. Okay. Now the rest you agak-agak lah, you read through a bit lah. Okay, so we will go to the experiment now. So like jump. For reach 10 to calories. So maybe if we have time, then we'll come back for this one. Okay, but for now, you can turn to uh 18, page 18, question number 5. Okay, good. Okay, so it looks like that. Similar picture. So the first one is knob solution. Knob solution means everything. Give you everything. The healthy one. Okay. Then the question here gives you without phosphorus, without nitrogen. Okay, without phosphorus, without nitrogen. There's no potassium involved here, right? It's okay. Whatever question wants to only ask these two, then that's all right. Okay. So now there you go. Observation. So what should we write? You know why I say that we should write only the color is because right in exam, right? We usually use seedling. Okay, we use seedling. So seedling means you can only look at the leaf. There's no flower, there's no fruits, and then the roots is so it's covered below. So the probably the only very obvious observation is the leaf. So you just have to write the leaves. You good? That's why lah. Okay, okay. Like for experiment purposes, then we just memorize the leaf. So for K is phosphorus, right? Lack of phosphorus. What color? Lack of phosphorus. Phosphorus. Oh, this one. Bluish green or purplish. Okay. Then for nitrogen is yellowish. Okay, yellowish. This one. And so this one and this one. Okay, good. Okay, let's write it down. Okay, then I also would like you to try on the responding and manipulated, which is from the experiment. Okay, you can go on, but you can write down the color for now. Okay, so you try on. Okay, so yeah, done for observation, right? Okay, so your responding is yeah, we just did responding, right? Which is the color of the leaf, but usually we will say the growth lah. Okay, the growth of the seedling, whether
healthy or not healthy or whatever color it is, that's the growth of the seedling. Okay, so your manipulated will be, I'm using different solution, right? Yeah, I'm using NOx solution, I'm using without phosphorus, so that will be the manipulator, will be types of culture solution. Okay, types of culture solution. Okay, right, you all got this correct. Hopefully, because that's very straightforward. Okay, what's the function of J? J is the one that has everything healthy. Then why are you here? Are we here to test without this, without that? So remember this experiment, you will have this complete culture solution here to act as a control set. So a control basically means I'm here to show you what is okay and what is not okay. Then you can make a comparison. So usually experiment, they have a control set to show you or to make comparison. Okay, so there you go. Okay, good. Why are the tubes covered with black paper? Okay, so black paper, quite a standard procedure though, like if you look at this one. So black paper is here to block the sunlight because if sunlight goes into the culture solution, right, the solution will grow algae, which will affect the result because the algae will fight nutrients with the roots. Then that's not something you want lah. That will disturb my result. So the black paper is to block sunlight, to prevent sunlight from entering. Okay. If it's 2 marks, then you can go on by saying to prevent sunlight from entering, to prevent growth of algae. Usually 1 mark, then we just say prevent sunlight. Okay. Then conclusion. Okay, you good. So the conclusion here is trying to prove to you that you are healthy. You must eat everything. You cannot don't want this one, don't want that one, not healthy, right? So in this part, we are here to prove that plants require the three macro. By the way, the three macro will be NPK, nitrogen, phosphorus, potassium, to grow or to become healthy. Okay, so plants require or plants need nitrogen, phosphorus, potassium. So I'm gonna list all three up. Although the question just two, but it's okay. You can list all three up for healthy growth. Okay, you good? So the next part will be nitrogen cycle. So I was thinking about this nitrogen cycle will actually take quite a long time to talk about the whole thing. Make sure you remember and understand the process, and then you need to memorize, and we can do the question. So since I have a video of it in my YouTube, uh, an old video, so I'm thinking I'm going to skip this part so I can go on to another part because chapter 2 is quite big. So for nitrogen cycle question or nitrogen cycle topic, you all can actually learn the whole thing if you want from A to Z, the detailed version. You can go to my YouTube channel, just search my name, Yu Qin Science, and then you search nitrogen cycle. You will see the cycle question, the teaching video. So I think I'll skip that because chapter 2 is very big. So we want to go to the next part. I have like 4 questions for you to try here. Number 6, 7, and 8. You try. Got 3 questions, okay? So that's to continue from here. Okay, you just watch and help yourself so I can save some time. So the next part will be 2.4. 2.4 will be food production. So how to improve food production? Use good quality of breeds. Okay, use good breeds. What is good breeds? These are the examples of the characteristics. Okay, and then use modern technology, educate the farmer, continue to research more, and take care of the land and the water resources, and manage land properly. Okay, so these are the criteria how to manage or how to improve food production. Okay, then down to biological control. Biological control, very simple. We learned this in like Form 1, Form 2 also. Basically means that you don't want to use any chemicals. You want to use natural prey predator to control your pests, like rats, grasshopper, and snail. Okay, so the advantage of pesticide, the good thing about pesticide is very fast, easy. The disadvantage is pollution. You kill everything, not necessary. Also, you kill things that are useful, right? Like earthworm and whatnot. Okay, and expensive. So like we encourage biological control because biological control is the opposite, more environmental friendly, does not kill other organisms. But the disadvantage is not effective, very slow, difficult to control. Okay, but in reality, we all use pesticide on so mafan. You use biological control, you want to weigh, you want to get the correct animal. So in reality, we don't. Okay, in farming, we all use pesticides or medicines. Okay, very simple topic. Go through the details, try out some exercise. Okay, like 2.5. Okay, this will be I would say, more important part. Okay, food processing technology and the chemicals that we add into it, right? Oh, this one, right? Okay, each of the method here has its own special method or characteristics. So you want to go through the details also, but I think we can try some work, try some exercise, and I'll come back to talk about it. So maybe 24, page 24, question 12, page 24, question 12. Okay, so diagram below shows a method of food processing for grain. You know what's grain? You know, like rice, that kind of category. Name the method. What is he doing? Or like, so you can go for kick out method, when you do exercise. Like, do you think is like he's cooking? Like, is he cooking the rice and cooking himself in a pot together? Obviously not, right? So you do kick out method. So do you think he is fermenting? Do you think it's dry? Do you think it's pressure? Do you think so? It's going to be awkward if I go on. Because it's so obvious that you must remember the food type and what method we use. If I give you a canned picture, of course, it's a canning method. If I give you a fresh milk picture, it must be pasteurization because you have to know the food and the method. So what are we doing here is all the dried stuff. So all this grain, right, we have to dry them up, like we have to dry the moisture away. So this method is called dehydration, obviously. Okay, so like dehydration. And explain the main characteristics. So what's the main point of dehydration? Isn't that obvious? Only dehydration is doing this, which is to remove the water. None of the processes removes water, right? So this is the only one that removes water. Okay, so like remove water, so that microorganisms cannot grow. The thing is, because the command word here says explain. If the command word says state, then you just say remove water. But because the question says explain, so no choice, we have to further a bit. You cannot just write remove water. That doesn't explain much, right? So you need to follow the command words. Okay, good. Okay, good thing about dehydration. Well, that's the oldest way of keeping food, right? When there's no technology, you just dry everything up. Can keep for a very long time, right? Dried food can keep a very long time as long as there's no moisture. So the good thing about dehydration is you keep a very long time. Food can be kept for a long time. Okay, can be kept for a long time. But the disadvantage is, lah, we don't actually every day eat all this because no, apart from the rice, apart from the rice, yes, we eat rice, right, every day, maybe very frequent. But most of the dry food disadvantage is not much nutrient. Okay, not much nutrient because of no moisture, because of sunlight, right? You kind of destroy most of the nutrient. Okay. So some of the nutrient may be destroyed. Okay. So the most popular method of storing food nowadays is canning. Canning, right? Explain the step. Oh, GG for 3 months. So like I said, those technological method you need to memorize a bit. Pasteurization and canning need to memorize already. As in because there is like temperature, there is like timing. So you memorize a bit lah, because more common question is this two pressurization and canning. So since we're here, canning. So three main point. Number one, 115 high pressure, high temperature, high pressure. Number two, remove air. Okay, suck out all the air. And then number three, heat up again to kill the remaining microorganisms and cool down quickly. So mainly you have three main parts. That's why you have 3 points here. But anyhow, it's the whole thing, actually. So, at least you copy one time, lah. You know how it works. The pasteurization also important because there's two temperature involved, 63307215. So you memorize these two sets of numbers, 63307215. Okay, you good? Then I'll talk about the chemicals a little bit. Chemicals, like moving in 5 seconds, yeah. Okay, let's go. Now, like I said, canning, memorize, and then pasteurization also. 63307215. So it's minute and second, they are correct. Okay, minutes and second. Okay. So we don't go to high temperature because we need to keep the nutrient. The good thing about pasteurization, all the dairy stuff like milk, juices, we want to retain the nutrients, so we don't go up to high temperature. But the bad thing is it will spoil very quickly, like milk. So give and take, give and take. Okay. Then of course the rest, yeah, you want to go through like vacuum packaging, remove air completely, so no air, no growth for microorganisms. Um, yeah, so you want to go through the rest. So chemicals, of course, you ask me memorize, so I don't want to memorize lah. Xiao mei, so many, huh? At least I know the function and I aga lah. So pasteurization, preservative. I was saying pasteurization. Preservatives are to keep the food fresh for a longer time or to prevent growth of microorganisms. Yeah, every food packaging or every food substances now we have preservative. Coloring, you add color to look more attractive because the original color is never attractive. Imagine cooking, like normal cooking at home, right? If you put in refrigerator, the next day your dishes looks not appealing anymore, right? Because the color will go away. So we add coloring in food packaging lah. Bleach is to remove color. Certain things that you want it to be in white color, we remove color like mee hoon lah, rice lah, sugar lah, we bleach them. Okay. Flavoring is to add flavor. All the food packaging we buy, all the food we buy outside, for sure there is flavoring. Artificial one or original one or whatever. We actually talk about this in Form 5, Chapter 5, right? Currently, esterification, flavoring. Stabilizer and emulsifier together, especially for sauces. Because usually sauces involve water and oil. Water and oil can never get together one. So we use emulsifier to force them together. And then we use stabilizer to stabilize and lock them into their texture. Okay. Sweetener, of course, to make things sweet or to replace sugar sometimes for diabetes patient. Antioxidant is to slow down oxidation, like oily food. Any oily food, they will oxidize with the air very quickly. So we will add antioxidant to stop oxidation. Okay. So agar you know the function, then the chemicals, don't worry about it. You can always try your best to guess the answer lah sometimes. Okay, then down to impact on health, some health supplements here, and then the food labeling, food regulation 1985. So these are all the labels that a food must have lah, in order to be on sale. Okay. So I think I have one about it. Can we, like one last question maybe? Can you jump to 26, page 26, question 15. Is it 26 for you? Can you find question 15? Question 15. Okay, based on diagram 4.1, state the most suitable food processing for X and Y. So by the way, this is called potato. Potato must use what method? So you try to find out potato. So potato, all these roots vegetables. Roots vegetables. Potato lah, onion lah, garlic lah, what else? Carrot lah. We always go for irradiation. Okay, irradiation is a method to use like rays to kill microorganisms and stop the roots vegetables from growing so they can be stored longer. Okay, so anyways, it's irradiation. Like you can write for number one, irradiation. So then the next one, Y is meat, right? Meat, where do you all have your meat? In your freezer one. So meat must be freezing. So number one is X is irradiation and then Y is freezing. Okay, freezing. Good, okay, jump. Next. One advantage of using food processing in A2 Why freezing is good? Well, freezing, honestly, all the advantage here is the same one. Why do we do all this method? So the food can keep longer, huh? Right? Isn't that the advantage? Right? You want to keep the food longer. Okay. So, yeah, there you go. So that the food can keep fresh for a longer time. So freezing, if you do it correctly, the food or the fish or the meat can keep for a long time. Okay. Okay, good. Diagram 4.2 shows the food label for ambang tomato sauce. Okay, so this is the food label, but obviously not so complicated like this one. This is a lot of things, but let's see what question wants. Usually food label, they will ask you to write down, maybe they ask you to find like things inside. For example, if you look at this one, right? Do you know which is your preservative? Oh, GG, right? Preservative, my God, I didn't memorize, but I think the one that looks like chemical. So it's called benzoic acid preservative. Show you. Benzoic acid preservative. You try lah. I mean, if really cannot, that is just gonna be 1 mark, right? Don't stress. There's still so many things you need to do in your life, right? Don't stress. This is okay. What else? If question asks for what will be the flavoring, flavoring. So flavoring is what? Salt, sugar, for example. Okay. Anyways, question. State one information should be in the food label according to regulation of 1983. Okay, so honestly, very simple. The most important thing you must always look for in the food labeling whenever you buy things is you look for the what is missing actually? Expiry date is here. I was about to say expiry date, but luckily I did not. Then that would be very awkward. Expiry date is here. I was saying like, sure, expiry date is not there one. Usually. Pay for why got expiry date? Then what is that? Name you have, ingredients you have, statement of the preservative you have. What else? Date. Date is already there, right, isn't it? So many more. But no, I think more importantly is the ingredient. No, what am I talking about? The net weight. So it's not stating the amount. Actually, got one more also very important. The manufacturing information is not there also. Okay. The manufacturing, these are important ones. Okay. So maybe you can say net weight, or you can say statement of quantity, or you can say manufacturing information. Up to you, either one you choose. Okay. Good. Okay, last question. Okay. Vacuum packaging is an important processing technology to prevent the growth of microorganisms in the package and stop food oxidation. So vacuum packaging means you remove air. No air, no microorganism. No air, no oxygen, no oxidation. Design a vacuum packaging for durian. So easy. But because this is where you do it at home, right? That's the challenging part. If you want to vacuum pack something at home, but you don't have the machine, this is what you do. The tips is here. Basin and water. Can you think of the answer already? Yes, no, no, yes. Okay. So you will have a basin of water. And then the Ziploc bag you place into the water with the durian. Okay. So like how when you try if you place the Ziploc bag into the water will actually squeeze the air away. So that you vacuum pack the Ziploc bag. So the Ziploc bag is here. So this is water. you'll get what I mean, right? When you place a bucket of water with a vacuum, with a Ziploc bag into it, you try if you have this at home, the water will remove air away. So then when it's down to the zip head, then you zip, then okay, vacuum packed already, the durian is being vacuum packed. Okay, so we label a bit. This is the basin. This is the Ziploc bag. This is the durian. This is the water. Okay, there you go. So make sure you draw. I mean, don't have to be very nice, man. Look at my drawing. Then you label everything. Then it should be fine. You good? Now, chapter 1 done, experiment done. Chapter 2, most of them done, but just the nitrogen cycle. Please help yourself with nitrogen cycle in my YouTube channel. And then experiment, we have two. One is the calorie value one, and then the other one is the nitrogen, the NPK experiment, which I have the question here. I mean, no, your one doesn't look like that, but you have it correctly with yours. So what you want to do is, if you really cannot do it on your own, you just download my answer. You try your best to follow and try to like remember a bit how you want to do it. Then that's the amount. That's what we have for your experiment. Chapter 3, you do have also got one, which is the methylene blue solution, biochemical oxygen demand. And then chapter 4 is the entire chapter experiment. Remember your rate of reaction? Yeah. So at least we cover 1, 2, 3, 4. I will do it in normal class. So for those who are attending physical class, please bring your seminar material along. Okay, for those who are attending physical. For those who attend online class one, it's just at home, it's easy for you to get the book. Okay, you good? Well, I hope these 2 hours help you a little bit and cover maybe half of your exam chapters. So I will continue the rest and I'll see you guys the next week. I'll see you guys someday. Okay, right. Peace, everybody. Goodbye. I'll see you around. Ciao, ciao. Goodbye, goodbye.